Hello guys, this is Prime Concept. We're back again, this time still analyzing the concept of quadratic equation. I did an introduction, very basic introduction to quadratic equation in our previous video. If you have not seen that, just go to my channel, check the playlist on quadratic equations. You will see that. So you can learn from the basics. I taught what quadratic equation is, how to identify quadratic equation. We looked at how to factorize quadratic equations using the formula method, and we saw the normal factorization without using formulas. So in this video, we want to look at the types of roots, or you can say the type of solutions a quadratic equation can have, right? Now we're going to start this way by recalling the quadratic general formula. So the quadratic formula is given by x equals minus b plus or minus square root of b squared minus 4ac all divided by 2a. This is the quadratic formula. Now, when we say we want to consider the types of roots, now you notice that when you solve quadratic equation, it's possible that when you solve quadratic equation, you would get real answers. You would get answers, normal answers. Say you would get x as 2, x as minus 3. These are real numbers, real answers, right? It's also possible, just like you saw in our previous video, that when you solve quadratic equation, you will end up having a negative sign inside your root. When you get a negative sign inside your root, that answer is said to be imaginary. We call it a complex answer, or we say it is not a real answer. Whenever you get negative sign in root, it gives us what we call complex number, or you can say imaginary number, right? Yes, so quadratic equation can lead us to those kind of solution. And it's also possible that when you solve quadratic equation, you'd get, it looks as if you have one answer. But remember, quadratic always has two answers. But it looks as if you have only one answer, but you call that coincident answer. It means that you say probably you got x as 2, but you say you got x twice as 2. So these are the different kinds of solution we want to consider. When we get deep into it, you really understand what it means. But take note, we want to look at the different possible kind of answers for x we can have. That is what we call types of roots. And this can be gotten from the knowledge of the quadratic formula. So from this formula, what we have in our square root actually is the factor that determines the type of root every quadratic equation would have, and we're going to isolate that and use it. Now, I will call it capital D, which is going to be b squared minus 4ac. So this quantity you're seeing determines the type of root a quadratic equation would have. And this b squared minus 4ac is called discriminant. Discriminant of the solution. So if they say what is the discriminant of a quadratic equation, it is b squared minus what? 4ac, which is very important to us. Now, we want to look at these different kinds of roots and which are determined by this. So number one, if our discriminant, which is b squared minus 4ac, if, okay, let me write it properly. If b squared minus 4ac, which is our discriminant, if it happens to be greater than 0, then the type of solution or root we would have, then we have two distinct or different real roots. So whenever our discriminant b squared minus 4ac is greater than 0 means positive, right? So when our discriminant is positive, it means that we have two distinct. When you say distinct, it means two separate real roots. That is to say the values are different. Say x is 2 and x is 3. These are different values, but they are real roots. You still understand when we take an example. So this is one. Now, if say we want to draw the graph, this is how it would possibly look. This is how it will possibly look. You have something like this. You have something like this, and these points are where you have the roots. So they are lying on your real. So whatever value you have here, say this is x1 and this is x2. So these are the roots. So this is how the graph would be. Of course, not just like this. We can invert it the other way. Yes, depends on the solution. So this is what you would expect. So number 2, if b square, which is our discriminant, if b square minus 4ac is equal to 0, then we have equal or coincident roots. So we say we have equal or what? Coincident roots. Equal or coincident roots. Equal or coincident roots. Real, of course, but they are what? Equal or coincident roots. And that root is actually given as going to be x equals minus b over 2a. This is what the root is going to be, right? Now, when you plot the graph, this is how it should look. You'd have it just at one point. So you'd have it say like this. So just at one point. So this is the value of x. So this is x1 and this is also x2. So the two values will be the same. You just get maybe x as 2. But what it means is that you got x1 to be 2. You also got x2 to be 2. That's why we say they are coincident equal roots. They are equal roots or coincident roots. So this is the second case scenario. Then number 3, which is the last type of roots we can have. We can have 3 types. Number 1 is real distinct roots. Number 2 is coincident equal roots. Then number 3, if b square minus 4ac is less than 0, then we have no real roots. You say you have no real roots, or you can say you have, or you can say we have imaginary or complex roots. So you say you have imaginary or complex roots. So when you have your discriminant to be less than 0 or your discriminant should to be negative, it means you have no real roots. Or you say you have imaginary roots, or you say you have complex roots. So that is the third case scenario. How would the graph for that case be? The graph is going to look this way. So you're going to have something like this. You see that the curve does not touch any point on the x-axis. So in this kind of case, you have complex or you have imaginary root, because the roots are actually where the curve touches the x-axis. So you see that in this case, the curve touches the x-axis at only one point. And that is why we have coincident root. But in this case, it does not touch. So it means it is imaginary, right? It is not real. So these are the 3 types of solution quadratic equation can have. So let's see an example that can help us understand what we have explained. So let me drop a problem. All right, now we have this very simple starting example to help us understand. The question says, if the roots of the quadratic equation, this is the quadratic equation, if the roots are equal, very important, find p. So where is the quadratic? Let me write it out. 3x squared minus 5x plus p equals 0. So you see that we're supposed to have a value for p, but they want us to find p. They told us that the roots, this quadratic equation, have equal roots. So if it has equal roots, we should find the value of b. Now, I gave 3 conditions. So one of the conditions would be used, which is condition 2, which says a quadratic equation have equal roots if b squared minus 4ac is equal to what? 0. So whenever this is equal to 0, it means that the quadratic equation have equal roots. So since they've told us this, we just use this directly and we'll find the value of p. So let's first of all identify our a from this equation. Our a is the coefficient of x squared, which is what? 3. Our b is the coefficient of x, which is what? -5. Our c is the constant that does not carry x, which in this case is what? P. So I'm going to directly substitute into this formula to find. So my b is -5 squared minus 4 into a, which is 3, and then c, which is p. Then this should be equal to 0. So -5 squared is actually 25. Then I have this times this is 12. So minus 12p equals 0. So what I'll quickly do is to say 25 equals, when this crosses, it becomes 12p. Or I would say 12p equals 25. So that when I divide both sides by 12, I would have that p becomes what? 25 by 12. So I've gotten the value of p just by the simple application of what we have done. I'll drop one more problem before I conclude this video. Then subsequent videos, I'll be solving more examples to help you balance out this knowledge. Now let's take one more problem to solve. All right. We're going to consider this other example as our final example in this video. And the question says, for what range of values of k does the quadratic equation this have complex roots? For what range of values? So you see k is an unknown in the quadratic. So let me write it out. 4x squared plus kx plus 1 equals 0. For what range of values of k does this equation have complex roots? So you would notice that this is our condition 3 that we gave today. Condition 3 is the condition for complex roots. And that happens, a quadratic equation would have complex roots if b squared minus 4ac is less than 0. So this is the condition for complex roots. So the first thing we want to identify would be our values of a, b, and c. So from this equation, a is 4. B is the coefficient of x, which in this case is what? K. Then c is the constant, which is 1. So I would substitute into this formula so that I would have that b is k. So I have k squared minus 4 into a. What is my a? My a is 4 and my c is 1. Then this should be less than 0. Remember, this is an inequality. So you don't solve it the way you solve normal equations. So follow so that you can really understand. So I have k squared minus 4 times 4 is actually 16. Yeah, it's 16. So this is less than 0. So we want to find the range of values. So it's an inequality. That's why they are saying range, right? Not just the values of k, but range. Now, how do we solve inequalities? Very simple. What first step I want you to follow is to ignore the inequality. Solve as an equation. So I'll do this. Follow me. So I have that k squared minus 16, I would equate to 0. I'm ignoring this for now, right? Now, I would have that k squared is equal to 16, so that k becomes plus or minus square root of 16, and then k becomes plus or minus what? 4. So we have the values of k, but this is not what we are looking for. Remember, I'm solving an inequality. And I say the first step is ignore the inequality, solve for k. Second step, you produce this on a number line. So this is negative infinity on your number line, and this is infinity, is a usual thing. So I have two values of k. One is -4, which is the smallest, and the other one is 4. Now, since I am dealing with a less than simply means these two values will meet each other. So if I'm moving from this point, I will go towards this. When this one is moving, it will come towards this. So whenever you have a less than, it means that the two values would move towards each other. This is just a short way for you to learn it. So this would move towards this would approach this. So if you look at this sign here, if you look at this is what sign? Is a greater than. So you can just say that 1 is that k is this sign which is greater than, what is the number below, greater than -4. And then you say that k, what is this other sign now? This sign is a less than. So you say k is less than, what is the number there? 4. So these are the values of k for the inequality. So, but a better way of putting those values is to simply say, if you want to combine this, whenever you're dealing with a less than, you usually want to combine your answer. And how do you combine your answer? You place k at the middle and make this less than sign, since you're dealing with a less than, right? This is only applicable to less than in inequalities. Don't use this when you're dealing with greater than, because it does not make sense. It's only applicable to less than. So you place this. Now I have k less than, so k is actually less than 4. It means I'll place 4 here, and then automatically I place -4. So this is my answer. This is my answer. But in case this is not also in your option, another way to write this is to use the bracket notation. So you say -4, comma 4, then you use this open bracket. So it's either you see this or you see this in your answer. One of them will be present in your answer. So I believe at this point the concept of roots in quadratic equation is clear to you. In my next video, I'll take more examples on this, and then we'll dive into alpha, beta roots of quadratic equations. So do well to subscribe to this channel if you are not yet subscribed, so that you'll be getting my constant updates. And I'll see you share this video with your friends, and then see you in my next video. Thanks for watching Prime Concepts.